Welcome to my video on truth tables. So in this video I will show you an easy method on how to set up for any Boolean truth table. Then I will show you how to use the truth table. But before we can carry on, be sure you have some knowledge on the following areas. You're going to need some knowledge on Boolean algebra and also logic gate. Now I have video on both of these, so if you want to go and search them both on my channel, then come back to this video and then we can carry on. If you do have some knowledge on them, on the subjects, then don't let this guy stop you. Let's start by drawing the truth table for a single variable, not a. Now I'll show you the method that I use. So step 1, we write down all the variables we are working with, putting them in their own column. So we have a single variable up here. So let's put a in its own column. We will start building the truth table in the top right hand corner. However, we don't know how many combinational rows we need. So this brings us on to the next step. We use the following formula to determine the number of combinations that are possible. So the formula is 2 to the power n, where n is the number of variables. Because we only have one variable here, we put a 1 where the n is. So the answer is 2, which means we have 2 combinations from one variable. So now we just need to add 2 more blocks here where we're building the truth table. And we move on to step 3. Now step 3 is when there is more than one variable. So I will show you step 3 in my next example. So because a is a Boolean variable, it has 2 possibilities. So it can be either 1 or 0. Now the order in which we place them into this truth table here, that doesn't really matter. However, we do tend to place them in ascending order, so 0 and 1. Step 4, we create another column for the expression we are looking for. So to create another column, we create it here next to the truth. So the expression we're looking for is not a. So there's the other column. Then step 5, we basically just fill in the table. So the first column a here is the input, and the column not a here is the output. I mean, you can see this with the not gate at the bottom of the screen here. So when a is false, the logic turns it into the inverse or the opposite, which will be true. So there we go. So when a is true, the logic turns it into the opposite, which is false. That's how a single variable truth table works. Now let's try the same method with 2 variables. We need to find the outputs for the expression a and b up here. So step 1, again, we write down all the variables, putting them in their own column. So there we go, we've got 2 variables, we put them in their own column. Step 2. Now let's find the number of combinations that 2 variables produce. So we place 2 into the formula, if you remember, because this time we have 2 variables and n is the number of variables, so we place 2 in there and then we compute. So 2 variables makes 4 different combinations, so we have placed 4 columns. So there we go. Now this is where we can start using step 3. So now we're going to get a load of combinations. To establish the order in which we place the combinations into this truth table, we firstly number each row in decimal, starting from 0. So there we go. Then you just have to convert the decimal number to binary. If you don't know how to convert decimal to binary, just quickly visit my video on that. So here we go. So 0 in decimal is 00 in binary. So decimal 1 is 0, 1. Decimal 2 is 1, 0. And decimal 3 is 1, 1. So now we've filled our truth table with the combinations. So for step 4, we just create an extra column for the expression we are trying to find. It's the same as last time. And there it is. So step 5, again, we just evaluate the expression. So the expression says both A and B needs to be true. So for the output logic to be true. So looking at the first row here, what do you think the answer is going to be? So they're both not true, so the answer is not true. And again, they're not both of them aren't true. I know B is true, but A is not true, so the answer is 0. Again, B is not true, so the answer is 0. However, on the last one, it meets the criteria. A is true and B is true. For the last example, we will use the same method for 3 variables. So we now know the drill by now. We basically just write down all the variables, separating them into columns. So there we go. So step 2, again we use the formula. 2 to the power n, where n is the number of variables. In this case we've got 3. So we put 3 into the formula and we get 8 combinations. So we draw 8 sections in our truth table. So there's the 8 sections. Then we move on to step 3. Now you will start to see why step 3 is becoming more important now. When the number of combinations increase, it prevents duplicating or missing a combination out altogether. So we use decimal numbers to organize the combinations, numbering them from 0 in ascending order. So there we go. Now to convert the decimal to binary, decimal 0 is binary 0, 0, 0. And decimal 1 is 0, 0, 1. And so on. It's 0, 1, 0. Now for step 4, we create a column in our truth table for the expression A and B and C. So now we've done that. And step 5, we basically just evaluate the expression. So for the expression A and B and C, inputs A, B and C all need to be true. So in the first row, they aren't all true. So we should get a false, a 0. Nor in the next. So again, in the next, I mean 2 of them are true in the next, but 1 isn't, and they all need to be true. So it's 0 again, and again. However, decimal row 7, and here, A, B and C, they're all true, which meets our criteria. So A and B and C is true. So here is the method written out for you. Maybe pause the video, screenshot it or write it down. Okay? If my videos helped you out, then like and subscribe to my channel. So my next video will be more complicated examples of truth tables. If that's what you want, then follow the link.